All right, there we go. So this is lab number 6. And, it kind of just gives you a little introduction. And then it has some materials down here. There's actually 2 PowerPoints. One of them, that first one there, is a PowerPoint that comes from an anatomy book. And so I just kind of took it, made a couple modifications to it, and stuck it in there. But that second PowerPoint where it says heart structures to identify, that's the one you want to pay attention to, because that has the pictures that will be on the test. So what we're going to do is we kind of started on the book PowerPoint this past Tuesday. So we're going to look at that some more. And then once we look at that, we'll go to this PowerPoint and look at the actual pictures that will be on the test. And then below that is a video of me dissecting the pig heart. Okay, I made it last semester. I got the pig heart there on my kitchen counter, and I've got my phone on a tripod. So I'm basically vlogging, whatever. But I'm basically making a video, and I'm sitting there dissecting the heart and showing you things on the heart. And so you can watch that video. It's about 20 minutes long or so, and you can then do your dissection, or you can watch the video as you do your dissection. That's up to you. But the main thing is turning in your lab report. Okay, the lab report is what you get points for. So the lab report we're actually going to finish today. I'm going to give you the answers, and then you can just submit it, and we don't have to worry about anything. You don't have to wait for me to grade it and get it back to you. You already have the correct answers, and that way you can study that for the test next week. Good deal? This is that PowerPoint that goes with the book. Okay, so we kind of started on this the other day. I don't remember how far we got because all my physiology classes are on this lab, but I kind of stopped in different places. But I think we talked about, remember this little video right here? We kind of labeled it a little bit, and we talked about the valves. And so let me find a good place to stop this video. You got to stop it in the right place to where it won't have any kind of pictures. So let's see. Keep going. Keep going. Keep going. Right there. Okay, that's a good place to stop. All right, so let's kind of review what we talked about the other day. Blood is coming back through the back to the heart through veins, and it's coming in here, here, and over here. Okay, now this blood is coming from the body here and here, and it's coming in through these 2 largest veins, the largest veins in the body. One is called the superior vena cava, or vena cava, depending on how you want to pronounce it, and that's bringing in blood from everything above your heart. So your head and your arms are all draining into the superior vena cava. And then the inferior vena cava is actually the largest vein in your body, and it's draining everything from below your heart. So your abdomen, pelvis, legs, all that is, those veins are all collecting into this large vein, and then it's returning back, okay? Over here is pulmonary veins, which are bringing blood back from the lungs. And there's actually 4 of those. And so when you talk about the great vessels, are the vessels that are attached to the heart. There's 6 veins, okay, 6 major veins. There is a smaller vein that actually drains the heart itself, but it's kind of a small opening. But these are the 6 like large veins that are connected to your heart: the superior vena cava, inferior vena cava, and then the 4 pulmonary veins. The top chambers are called atria. So this over here is the right atrium, and please don't make that mistake. I think I mentioned that the other day, that you'd be surprised by how many times this mistake is made. It's a simple mistake, but it's also it's an understandable mistake to a point. When you're looking at something, it's like when the patient's facing you, this is your left, this is your right, okay? But you don't do that. It's always the patient's. So no matter how you're looking at the person, it's always the patient's right and the patient's left. And that really throws people off. I mean, the wrong body parts have been amputated before. I mean, think about that. because somebody made a simple mistake of right or left. It's always the patient's right and the patient's left. So when you're looking at the heart, the right side is actually over on the left side of your screen. And so this is the right atrium. This is called the right ventricle. Over here is the left atrium and the left ventricle. Blood always goes into the heart through the atria. Okay, the word atrium means entranceway. So when you're reading a question on either test next week, if you're reading a question and it says blood enters the heart, you know it's going to be one of the atria. Okay. Then you look for the second part of the question. Like you'll see a question next week. Blood returning from the body enters the heart where? Okay, that's going to be over here at the right atrium. Okay, so that's where blood comes back and enters the heart from the body. Then it's going to move to the right ventricle. And in order to do that, it's got to go through this valve right there. And we talked about these valves the other day, right? That guy's called the tricuspid, right? Mariah, I'm using you. Is it Mariah or Maria?
Mariah, like Mariah Carey.
There you go. So yeah, Mariah, I'm using you as my feedback because I can see your face. So that right there is the tricuspid. Okay. It's going to move through the tricuspid valve. It's going to go into the right ventricle. Then the right ventricle is going to contract and push the blood out. And so the blood's going to come this way, and it's going to make its way towards the lungs. And this great vessel here is called the pulmonary trunk. And then this valve right here is called the pulmonary valve or pulmonic valve. So that's kind of blood flow through the right side of the heart. It's going to go to the lungs, then it's going to come back through the pulmonary veins. And when it comes back, so if you see a question that says blood returning from the lungs enters the heart where, that would be the left atrium. So the blood's going to come back, go into the left atrium, then it's going to go down to the left ventricle. And to do that, it's got to go through that valve, which is called the bicuspid or mitral valve. And then the left ventricle will contract, and then the blood will go up into the aorta and then make its way back to the body. And that valve right there is called the aortic valve. So that's kind of the basic things that we talked about the other day. And so I could ask several questions from that information. And, I could ask blood, where the right ventricle, where does he pump blood? He pumps blood to the lungs. Okay. So he's going to pump blood into what we call pulmonary circulation. So you associate the right side of the heart with pulmonary circulation because the right ventricle pumps blood into pulmonary circulation. Then the left ventricle pumps blood into what we call systemic circulation, which is all the other blood vessels that are involved with the body. Pulmonary circulation, which we're going to learn the blood vessels associated with the different circulatory patterns in chapter 20. So that'll be on the second test. But you have pulmonary circulation, which is the right side of the heart to the lungs, and it comes back. That's very easy, okay, to learn. I mean, you have the pulmonary trunk, you got pulmonary arteries, pulmonary capillaries, pulmonary veins, and that's it. Systemic circulation, which starts with the left side, way more complicated. That's all the other blood vessels in your body. The blood vessels that take blood to your head, your arms, your abdomen, your legs, and the blood vessels that bring it back from all those areas are all part of systemic circulation. So systemic circulation is a lot more complicated than pulmonary circulation. And I told you guys the other day that you should look at the heart as two pumps, a right pump and a left pump, because they are different. They're physically separated from each other. We're going to see that today. They are pumping blood to different places. The blood in them is different. You'll see anatomical differences between the right and left lung. You actually, or the right and left side of the heart. You'll actually see anatomical difference between the right and left lung. We'll learn that later. But you'll see anatomical differences between the right side of the heart and the left side of the heart. One of them I showed you the other day, that the right AV valve over there has 3 flaps that come together to shut. And that's why it's called the tricuspid valve, while the left AV valve only has 2 flaps. and they call that the bicuspid or mitral valve. And I told you guys the other day the mitre. The mitre is a headdress that bishops wear in the Catholic Church, and it has two flaps, and so they call it the mitral valve because it resembles a mitre, the headdress. And so you will see the anatomical, and make note of those, by the way. Make notes of the differences between the blood in the two sides, and then note some of the anatomical differences between the right side of the heart and the left side of the heart. So are the pulmonary veins the only veins in the body that carry? Yes, that's a good question, Cassie. Cassie asked, are the pulmonary veins the only veins in the body that carry oxygenated blood? Yes, that is correct. And so it's almost like it's flip-flop from systemic circulation. In systemic circulation, the arteries are high in oxygen and the veins are lower. Okay. With the pulmonary circulation, it's the exact opposite. The arteries are carrying deoxygenated blood, and the veins are carrying oxygenated blood. So yeah, it's just flip flop basically because of where are they taking blood to? You know, good question, Cassie. All right, positioning of the heart. It's deep to the sternum. Now you may have to do this, by the way, next week. You know, I may ask you, describe the location of the heart. And what's funny is when I ask that, sometimes people are like, oh gosh. I'm like, you know, it's like probably the best known, other than your brain, it's probably the best known organ for people, right? I mean, my little girl who's 6 years old knows where the heart is, you know? And so you can't just put it in the chest. And that's what I get sometimes. I'll say, describe the location of the heart in the chest. And I'm like, nah, I mean, where's it at in the chest? You know, I mean, you gotta be more thorough. And so next week, whenever you have to describe the location of something, be as thorough as you can. It's better to over-explain than to not explain it well enough, because you want to be able to help somebody. Imagine that they're reading a medical chart. They should be able to find a structure based on your description. So you got to be as thorough as you can. So you can say stuff like, the heart is located deep to the sternum. That means it's underneath the sternum. And you actually get that, you think about that with chest compressions, because when you do chest compressions, you push on the sternum, and that pushes on the heart, and that's how you get chest compressions. But it's going to be deep to the sternum. It's tilted to the left, and so actually a good chunk of the heart is just slightly left of the midline of your body. And it's in the thoracic cavity, okay, which is the whole thing, but there's actually a smaller cavity, a smaller compartment right there in the middle of your chest called the mediastinum. And that's where the heart is. That's where the great vessels are that attach to the heart. That's where the thymus gland is that we looked at before. We're going to talk about the thymus again with the immune system, but there's a gland that kind of sits on top of your heart that's important for the development of the immune system. And then you have a portion of the trachea. All those are just kind of in that area there. So it's kind of like a little box right in the middle of your chest called the mediastinum. And I always thought, you know, mediastinum sounds a lot like middle of the sternum. And so that's how I remembered it. You know, I was like, mediastinum, middle of the sternum, that's about where it's located at. And so have a good quality description of location to use on the test. And you also want to use your anatomical terms. Like, you don't want to say behind the sternum, and you want to say deep, or you could say posterior because it's kind of the same thing. But a lot of times with that endocrine lab you guys did, I had you describe the location of structures, and a lot of people were using those words above, below, behind, and I put a little comment just saying, you know, practice using your medical terms, because that's what you're going to use in a medical chart. You know, you don't say in front of, you say anterior. You don't say above, you say superior. And so practice using your anatomical terms when you describe the location of a particular structure. But all throughout this semester, you will have to do that. You'll have to describe where something is. And you got to be, especially when you think about the abdomen, there's a lot of stuff down there, a lot of organs down the abdomen. And so you can't just say it's in the abdomen. You got to be more specific on where exactly. And if you remember from AMP1, that's why you divide the abdomen up into what's called quadrants, or you can do that tic-tac-toe board, and it divides it up into smaller boxes. So just, saying the heart's in the chest is not quite good enough. You got, if you say mediastinum, then that definitely narrows it down to a little box in the middle of the chest. So just be thorough. Don't leave it up to me to go, well, they came close. I'll give them partial credit, There's a sac around the heart called pericardium. The word pericardium means around the heart. Peri means around, like perimeter. So pericardium means around the heart. It's a sac and it has fluid in it. And the fluid helps to lubricate because the heart's always moving. And it also helps, the pericardium sort of helps to hold the heart in place so it's not bouncing around when you're moving. There is instances, though, where you get fluid buildup in this sac around the heart. And that really messes with the heart's ability to beat properly and to move properly. And that's called effusion. And so you have terms like pericardial effusion, which is the fluid buildup around in the pericardium. And so you will hear about that sac from time to time with that fluid building up in that area, or blood. Sometimes you can get infection in that area, pericarditis, that sort of thing. So you will hear about the pericardium, or they also call it the pericardial sac as well. And the fluid in there is called pericardial fluid. So as long as you understand pericardium means around the heart, that helps you to figure out everything else. The wall of the heart is mostly muscle. The word they use is myocardium. Myo means muscle. Cardium means heart. And actually they got 4 chambers. The 2 top chambers, the atria, are designed to sort of work as one muscle. So they're contracting together like that. And so you have the myocardium of the atria. It's like a single muscle. It's supposed to act like a single muscle. And then you have the ventricles that are supposed to contract together as well. And there is fat around the heart. And in fact, if you look at your pig heart, you'll be able to see a lot of fat. And you actually see it on this picture too, right there. All that yellowish, whitish stuff there, that's all fat. And so there's a good chunk of fat around the heart. And the reason why is because the heart uses fat as a primary fuel source. So whenever your heart's working, it's doing aerobic respiration and it's burning fat as a fuel source. And those of you guys that had me for AMP1, and I'm not sure about the other teachers, but in AMP1, we talked about this thing called glucose sparing. And what that is basically is your brain needs sugar, okay? That your brain uses sugar as its primary fuel source, glucose, and it needs a constant supply of glucose. It can't store it, okay, but it burns through it very quickly. And so you always need to make sure that your brain is getting sugar. And they say that about 20 to 25% of all the sugar that you put in your body goes to your brain. It's used by your brain, okay? So your brain has a large requirement for sugar. So what other body parts will do is use a different fuel source. They're sparing the glucose for the brain. They call it glucose sparing. For example, your liver burns fat as its primary fuel source. With your muscles, your skeletal muscles, when they're resting, they're burning fat as their primary fuel source, and your heart burns fat as its primary fuel source. So those organs will burn fat, and that way the brain gets the glucose, okay? So don't be surprised by, this is not an unhealthy heart. It definitely looks unhealthy. You're like, oh my gosh, look at all that fat. But that's actually normal in a lot of cases. Now, it may not have that much, but you'll still see a fatty heart. You can have a fatty heart, you can have a fatty liver. That just means you have more fat than you're supposed to. But we all have some fat around our heart because that's the primary fuel source that the heart uses is fatty acids. On the external surface, you've got some features. One is there's a deep groove on the outside of the heart between the atria and the ventricles on both sides. Okay, so you got your right atrium here, right ventricle, left atrium, left ventricle. And in between the atrium and the ventricle is this groove. So that's the groove in the heart. Going back to that song, the groove is in the heart. As a scientist, as a person who teaches A&P, whenever I hear that song, I think coronary sulcus. I'm an idiot. But you will see the world differently too, depending on what program you go into. That's called the coronary sulcus. Okay, sulcus is a word we use that means the groove on the surface of something. For example, the grooves on your brain. Okay, those are called sulci, but sulcus is one. And so this is called the coronary sulcus. That's the right coronary sulcus there. And then the left coronary sulcus is right here. And that's where the blood vessels run that actually supply the heart itself with blood, which we call coronary arteries and coronary veins. Now that sulcus will be easy for you to see on your pig heart. And that's one of the reasons why I like to do the pig heart dissection. You can hold it in your hands. You can actually run your finger into the coronary sulcus, and you can actually lift the atrium out of the way and see stuff. And so it's so much fun to have an actual heart in your hand, slicing and dicing it and sticking your probe and fingers into different places and stuff like that. So I hope you guys enjoy doing the pig heart dissection. And then once you do the dissection, once you watch the video and you do what I show you to do, after that you can do whatever you want to the heart. You can cut it any way you want to. You can do whatever you want, but just follow the instructions first, and then you can slice and dice it however you wish. Also on the heart surface there's an extension of the atria. It's this little muscular extension, and it looks like an ear sticking out of the heart, and that's called the auricle. And that's what we call this fleshy part of the ear is auricle. And so that's called the auricle of the heart. There's a right auricle and there's a left auricle. So those are the two ears sticking out of the heart. Sometimes they look like a human ear. Sometimes to me, they kind of resemble a flattened ear, like a dog, like a beagle's ear or something. But you'll be able to see those also on your pig heart when you're sitting there messing with it. And what the auricles do is kind of give the atria a little bit of extra space to receive a lot of blood. So it kind of gives it a little bit of extra expansion ability. Because when you're huffing and puffing, when your heart rate's very high, you have to pump a lot more blood through the heart than you normally would. Typical cardiac output when you're resting is about 5 liters a minute. When you're huffing and puffing and your heart rate's really high, it can be up to 5 times that. It can be up to 25 liters per minute. So when you're going balls to the wall, when you're really exercising hard, 25 liters of blood are pumping through your heart every minute. So it's got to be able to very efficiently bring in all that blood and pump it out. And so the chambers have to be able to expand, so to speak, to accommodate that extra blood when you're going through those activities. And so that's what the auricle is kind of used for, is to give it that little extra expansion ability. And I think that's most of your external features. There is one more, which is a very obvious artery that runs down your heart. So this right here is just a recap of the chambers and the valves. Then it kind of goes through the circulation patterns, which we covered. And okay, this is a good point right here. You're going to see this when you do your dissection. You're going to cut a window, a little box, into each chamber using your scissors. Okay, so you're going to go to your right atrium and you're going to cut a little square in it. You're going to go to the left atrium, cut a square. When you get to the left ventricle and you go to cut into it, have fun with that, because the left ventricle is extremely thick. It's like cutting into a huge, thick, burnt steak. It actually took me 3 rounds. Like I cut a little square, just a shallow square. Then I cut a little bit deeper, and I cut a little bit deeper before I actually punctured through the outside wall of the ventricle. So you got to really jab your scissors into the ventricle to get through that wall. That wall is very, very thick. So it's going to be tough. I mean, your hands might start hurting from using these little scissors to cut this square into that particular chamber. The right ventricle is not as hard to cut into because the left ventricle is about 3 times thicker. Now, the reason why goes back to where they're pumping blood to. The right ventricle only has to pump blood to the lungs, which is like right next door. So he doesn't have to pump it very far, and he doesn't have to generate as strong of a push. The left ventricle, though, has to pump blood everywhere else. So he has to generate enough pressure to push blood up to the top of your head, out to your fingertips, down to your feet. And so the left ventricle is a bigger, stronger muscle because it has to generate the higher pressure because it's pumping blood a lot farther than the right ventricle is. Now, once you get done with your heart dissection, if you wanted to do a transverse cut, okay, cut across like this picture right here, you can do that. Once you get done with your dissection, you just cut across. It's going to be tough, though. You might have to get out like your Ginsu knife and slice through the heart that way. Because you're not going to be able to do that with your little tiny scissors they give you in your box. There's the 2 circulatory patterns. So it just kind of shows you the pulmonary circuit and the systemic circuit. And then you get a little table there, the valves. Okay, here's the last external feature that you have to know for next week's test. The very first organ to get a blood supply is the heart. Okay, so right outside the heart, your aorta is coming out. Okay, so your aorta is going to be taking blood to the body. And so here comes the blood. And it's going to go to all the different places in the body, your arms, your head, your lower body. But just outside the heart, there are 2 branches coming off the aorta. And they're actually supplying the heart itself. And they're called coronary arteries. You got a right coronary artery and you have a left coronary artery. And so those guys, the very first organ, and it makes sense if you think about it. If the heart doesn't get blood, nobody else does. And so it's the first organ to get a blood supply once the blood leaves the heart. Okay. Blood's going to go into here. Then it's going to travel down the coronary sulcus, that groove. The coronary artery travels down the coronary sulcus and it gives off branches that supply the different areas of the heart. Okay. So you have the right coronary artery here and the left there. Now go back to the jobs of the 2 different sides. In general, left side problems are worse than right side problems of the heart. For example, if the right side of your heart's not pumping strong, that's not too bad. I mean, obviously you want everything to work perfectly. But if the right side of the heart's not pumping very well, the good thing is about that is that blood doesn't have to go very far. And so, you can it's a lot easier to deal with a right side problem. If the left side's not pumping well, that means everybody else isn't getting a blood supply, including the heart itself. Okay. So when you're looking at the heart and you're looking at the 2 sides, if I had a choice, which I might later on in life, if I had a choice in heart problems, I would choose a right side problem. Left side problems can be devastating because that means your brain's not receiving blood at the proper amounts. That means all your other organs aren't receiving blood at the proper amounts. But like I said, ideally you don't want problems at all. Now my dad had double bypass done about 5 years ago, and I was looking over his medical charts, and his right coronary artery was blocked like 95%. Okay, so it was basically almost completely blocked. Okay, his left side was only about 35% blocked, and I was like, well, Dad, you picked the right side to have a blockage, But these arteries here are a very common place for cholesterol buildup, fat buildup. Like if you eat a diet that has a lot of saturated fat in it, or if you eat a high cholesterol diet, or if you eat a lot of trans fat, all the bad fats. Or if some people are just genetically predisposed to having clogged arteries, But this is a very common place to get plaque buildup, is in these arteries here. Okay. Now I'm gonna draw a little blood vessel here. Imagine you have a blood vessel, and over here is any organ. Okay. You could be talking about the brain, You could be talking about the heart. It doesn't matter. And then imagine blood's coming in this way. If you start getting plaque buildup, so here's my little plaque buildup there. That causes a hardening of the arteries. They call that atherosclerosis. Atherosclerosis, athero means artery, and sclerosis means hardening. Okay. Atherosclerosis is a plaque buildup. Now, as you start getting plaque, we all have some plaque buildup. It's just, unless you have perfect genetics and perfect diet and all that, but all of us have some plaque buildup, and it accumulates over time. Okay. And yes, if you eat a poor diet and if you smoke and drink and do all those things, it could build up faster. But they're finding plaque buildup in kids as young as 7, 8, 9 years old when they do autopsies on them. They're showing signs of cardiovascular disease and atherosclerosis because of fast food and poor diet and lack of exercise and everything else. But you get this plaque buildup, that's going to reduce blood flow to that organ. All right. And what we call that, whenever you have a decrease in blood flow to a particular organ, that's called ischemia. Ischemia. It's I-S-C-H. The CH makes a K sound. Okay. So you might hear words like ischemic. Whenever you hear the word ischemic on your medical shows you watch, that means there's a reduction in blood flow to a particular tissue. And that may cause things like strokes and stuff like that, ischemia. This may do a chat. Let's see that. No, okay. So a decrease in blood flow is called ischemia. Now, if that continues to build, if that plaque continues to build and continues to build. Now, imagine this is the organ is the heart. These are coronary arteries. When you get that plaque buildup, you can have symptoms of ischemia. And a lot of times you may not have any symptoms. This is what we call it the silent killer. Because a lot of times, some people, their arteries are clogging up, but they don't have any symptoms, and so it's the silent killer. But sometimes with the heart, you'll see certain things like exercise intolerance, or if they start exerting themselves, they'll get chest pains, angina, and so you can see sometimes you can feel some symptoms of ischemia, and that's kind of your clue that, hey, a lot of people think it's a heart attack, and then they go to the doctor and they're like, well, but it wasn't a heart attack, but you do have a lot of plaque buildup in your coronary artery. So, and then they might do a study, they might do a stent placement or a bypass or whatever. But sometimes ischemia doesn't show any symptoms, and that's when it's really scary, because you could be feeling fine, and your arteries might be almost completely clogged. You know what I mean? Now there gets a point where it's so clogged that the blood can't get through. All right. Whenever you have a blockage, a complete blockage of blood flow, not just a reduction, but a complete blockage of blood flow, that's called an infarction. So ischemia is reduced blood flow. Infarction is a complete lack of blood flow. Okay, the blood is blocked from getting where it needs to go.
Is that like a heart attack?
Yes, and a stroke. Okay, so you can have an ischemic stroke, which means it's like a minor stroke in a way. A minor stroke would be like a reduced blood flow to a brain tissue, and it could cause a minor stroke. They call it an ischemic stroke. But you can also have a brain infarction, where a particular area of the brain, the blood flow to that area is completely blocked, and that's the major strokes that call major problems, because that doesn't mean that blood's just getting delivered in smaller amounts. That means blood's not getting there at all. Okay, and it's the same thing with the heart. If there's a reduction of blood flow to the heart, yes, it may affect the heart. You may have like a minor heart attack symptoms, right? But when you have a complete blockage, that means whatever tissue is being supplied by that blood vessel, it's not getting any blood. And so you can have a brain infarction that would cause a stroke, or you can have what we call a myocardial infarction, and that's the fancy term for a heart attack, okay, an MI. Myocardial means heart muscle. So a myocardial infarction means that the heart muscle is not getting blood. The blood vessel that's delivering blood is completely blocked. Now, depending on where that blockage is, that also sort of determines the severity of the heart attack. So if you look at this, if you look at these blood vessels over here, notice that you have a couple large vessels. You have your right coronary artery, you have your left coronary artery, and then you have this large guy coming down the front. All right. If you get a blockage in any one of those, that can be bad news. All right. Because if you think about it, let me erase that for a second. If you have a blockage, whatever body parts are distal to the blockage, after the blockage, okay, they're going to lose their blood supply. All right. Now, if you get a blockage, like, look at this guy here, this little side vessel, okay, that little branch right there. If you get a block like right in there, that means that like just a small section of your heart is going to lose its blood supply. So that might cause like a minor heart attack if one of those little side branches get blocked. Okay. If one of the large branches get blocked, so think about this, let me erase that there. If you get a blockage, let's say right here in the right coronary artery, that means all of this loses its blood supply. Okay. Because everything distal, everything farther away or past, everything past the blockage is going to lose blood. And so that would cause a much more severe heart attack. Okay, so depending on where the blockage is, that also determines how bad a lot of times the heart attack. You can have people who have like 7 heart attacks and still be alive. And then you have other people who drop dead from one. A lot of times that depends on where that blockage is. The worst place to get a blockage would be in the major coronary arteries. So yeah, if you get a blockage like right here, or if you get a blockage like right there, especially your left, and I'll explain why here in a second. But if you get a blockage there in your left coronary artery, then a huge portion of the heart is going to lose its blood supply. There's actually another, it's a branch off the left coronary, and it's this guy right here coming down the front of the heart. If you get a blockage in him, that a lot of times causes a massive heart attack. He's commonly called the widowmaker artery, because a lot of men, because men are more prone to getting cardiovascular disease and having heart attacks because of plaque buildup. But they call it the widowmaker because it's killed a lot of men, and they've left widows. You know, it's killed a lot of men. And so this guy here, and you're going to see this a little bit later, the reason why he is one of the worst places to get a blockage is because he supplies both ventricles with blood. All right. So the ventricles pump blood out of the heart. So if the ventricles lose their blood supply, they're going to stop pumping as well, which means that nobody gets its blood. The blood can't go to the lungs to pick up more oxygen. The blood can't get to the brain the way that it's supposed to. But another thing you're going to see here in a minute is that the nerve fibers that control the beating of the heart run down the middle of the ventricles. It's called the bundle of His. And then you have these fibers called Purkinje fibers, which are very important for the electrical conductivity that controls the rhythm of the heart. So getting a blockage in the widowmaker kind of short circuits the electrical activity of the heart and essentially shuts it down. And so that's a very, very bad place to get a blockage. Now his name, here's one name they give it: anterior interventricular artery. Interventricular means between the ventricles. But it's much more commonly called, like on TV shows and stuff, and in hospitals here in America, the more common name is left anterior descending artery. And they commonly shorten it up to LAD. So when you hear them talk about the LAD artery in the heart, that's the widowmaker. And you can see him on your pig heart. Okay, when you hold your pig heart, you look in the front, there's going to be an artery running down the middle. That's the widowmaker. the left anterior descending artery. I was watching a TV show last night and they mentioned it. They were doing a surgery on the heart and they mentioned the LAD.
Where the blood goes after passing through that?
The LAD, it's got side branches that are going to come out here and supply this part of the ventricles, of the right ventricle. These branches here, left ventricle, and all this here in the middle, basically. And so if you're looking for a box, the left anterior, the LAD artery supplies all of that right there, basically. And like I said, both ventricles. So a good chunk of both ventricles get their blood supply from the LAD and that nerve tissue. Now we haven't looked at the nerve tissue yet. You're going to see it here in a minute. But you know, the three most important structures of your heart, the two ventricles and the nerves that control the beating of the heart, are all supplied by the LAD. And so when you hear somebody say widowmaker heart attack, that's what they're talking about there. And a lot of times the person will be seemingly okay because, like I said, sometimes ischemia doesn't show symptoms. Sometimes it does, obviously, but sometimes it doesn't. It's a silent killer. But when it gets to the point where it becomes an infarction, you can have a person just have a massive heart attack and be done. And so they might be seemingly healthy 1 minute, and then something, then that plaque build up. Also, there's nothing stopping this plaque from breaking off and moving to a smaller vessel and clogging it up. Okay, so imagine that. Imagine you have a vessel, because blood vessels do taper. They do get smaller. Arteries get smaller and smaller as you move away. So if you have plaque buildup, let's say here, and a piece of that breaks off, it may travel down and completely block a smaller vessel further down the line. All right, and so that's another thing that might happen. Once again, though, it depends on where the blockage is, because even the widowmaker has side branches. So depending on where the blockage is, that may cause a minor widowmaker heart attack, or it may cause a massive heart attack. It all depends on where that particular blockage is.
So if it was to break off, is that like a stroke?
Can be, yes.
Okay.
A stroke typically is caused by plaque buildup in the carotid arteries, because the blood's going up to the brain, or in the actual arteries of the brain itself. But yes, same thing could happen. A piece of plaque breaks off, travels to the brain, and clogs up a vessel and causes a stroke. Could be a blood clot. Okay, it could be a blood clot that does it.
Okay, so it's a blood clot, and that would be called an embolism when it's blood.
Right. Yes.
Okay.
An embolism is a blood clot that has broken off. Okay.
All right. No.
What we're talking about here is a plaque buildup. Okay. Plaque typically builds up in your arteries. Okay. Blood clots typically happen in your veins.
Okay.
But they both can clog up blood vessels. They both can cause strokes. They both can cause heart attacks.
Okay.
All right. It's just plaque is more associated with arteries, and clots are more associated with veins. It doesn't mean you can't get plaque buildup in your veins. It doesn't mean you can't get a clot in your arteries. But it's just typically what we associate with the two. Plaque is more of an arterial thing. Clots are more of a venous thing. Everybody good? Obviously, you don't want any problems, but so whenever you watch these medical shows and you hear the word ischemia, just think that whatever body part they're talking about is not getting enough blood. All right, ischemia is like the body part's not getting enough blood. An infarction means the body part's not getting any blood. Zero, no blood. Okay, so it's a little bit different. And then, of course, an infarction is going to be typically going to cause worse problems than ischemia, because ischemia you're at least still getting some blood to the tissues, where an infarction just means nothing getting delivered. Chat. So is there a way to clean up the plaque, or is surgery the only way? Do you mean like is there a medicine you can take that breaks up plaque? there's actually diets that they say, quote unquote, scrubs your arteries clean. And you can look that up, by the way. You can look up foods that clean your arteries. And it's guys you usually associate with being healthy. It's okay, It's okay, Jessica. But yes, there are, cardiovascular disease, plaque buildup can be reversed, so to speak. All right. You would have to change your diet. There are some medications that do help to slowly, because once again, you got to be careful, because if a big piece of that plaque breaks off, let's say you're trying to dissolve a plaque. If you start dissolving it and a big piece breaks off, it could travel down the line, clog up an artery, and cause worse problems than you had. Does that make sense? Okay. So whatever you do, it's going to have to be a very gentle scrubbing, and you got to be careful with it. But yeah, there's actually diets. You just Google diets that clean your arteries, or diets that or foods that scrub your arteries, or something like that. Also, one of the things that causes plaque buildup in your heart is inflammation of the blood vessels. And so let me kind of show you what we're talking about there. Is that your blood vessel walls, you would like for them to be smooth. Okay, when they're smooth, things don't stick to them as easily. But if you have inflammation, that causes the blood vessel wall to have more of a bumpy appearance. Okay, more of a swollen appearance to it. Okay, go back to the blood clotting information. The inside wall of your blood vessels is called endothelium, or you'll hear it called endothelial lining. If your endothelial lining becomes inflamed, that makes it have more surface area, and that makes it easier for fat to cling to it. And so fat likes to grab or cling to inflamed endothelial walls. And some of the things that inflames your endothelial wall are things that you've known for a long time are not the best thing for you, like smoking, chemicals. So if you smoke cigarettes and those chemicals, those harsh chemicals are in your blood, or if you do drugs and you have those what are basically toxic chemicals in your blood, that inflames your arteries. And that makes it easier for the fat to grab a hold of and start forming a plaque. Poor diet, diets that are high in a lot of saturated fats. So certain diets will inflame your arteries. When the blood is done in the coronary arteries, they go through, yes. Candace asked, when the blood is done in the coronary arteries, do they go through veins back to the right atrium? Yes, coronary veins will pick it up, and the coronary veins all merge together into this. It's not a huge vein like the superior vena cava and inferior vena cava, but it'll come back through a coronary vein, and there's a little opening in the right atrium called the coronary sinus. And basically that's bringing blood back from the heart itself. So really you got three veins that are attached to the right atrium: superior vena cava, inferior vena cava, and then the coronary sinus, which is actually draining the heart itself. And so if you look at, let's see what we can find as far as, and like I said, when you see these types of lists, and things that inflame endothelium. So I'm sure we can find something here. Factors that trigger endothelial inflammation: stress, okay, the stress response, lack of sleep. So not getting enough sleep can inflame your arteries and make it easier for plaque to attach. It's inflammatory diseases of different kinds: obesity, high blood sugar, high triglycerides, smoking, doing drugs. Alcohol is weird because a small amount of alcohol actually relaxes your blood vessels and actually smooths them out. But too much alcohol inflames your blood vessels. And so that's why they say that, a small amount of alcohol, especially like wine, red wine, that will actually help with cardiovascular disease. But there is a fine line between, drinking moderately and drinking heavily. So heavy drinking inflames your arteries, while moderate or mild drinking actually smooths your arteries out. I tell you what, there's a really good documentary. I don't know if it's still on Netflix or, but it's called Forks Over Knives. And this story or this documentary is about this guy who he goes to the doctor and gets diagnosed with severe cardiovascular disease, and he hires a dietitian, and the dietitian puts him on a plant-based diet. So you're thinking like vegan, a vegan or vegetarian diet. And the documentary sort of watches his progression. Now he also starts exercising, you know, but basically he goes in and gets diagnosed with cardiovascular disease. He changes his diet, he changes his lifestyle, you know, exercises more, all that good stuff. But mainly what it's focused on is a plant-based diet. He goes back to the doctor like 9 months later and it's gone, or it's like, you know, it's severely reduced. So basically his arteries cleaned up over a 9-month span by going on a plant-based diet. Okay, so it is a documentary that touts veganism. Okay, it's made for people. It's made to convince people to become vegans. And I'm just going to be honest with you, right? But it is very compelling because it actually goes into the blood vessels and talks about all this. Talks about the inflammation of the lining and the plaque buildup and how different plants have different chemicals and vitamins that actually relax the lining and prevent inflammation. Another thing that helps with inflammation of the arteries and things like that is omega-3 fatty acids, which you get through like fish oils and things like that. And so a lot of this thing where they talk about this Mediterranean diet, which is like high in olives and fish and stuff like that. The reason why that's supposed to be better for your cardiovascular health is because it has a lot of things in it that reduce inflammation. Okay. And so if you reduce the inflammation, then the plaque can't stick to the wall as well. And that helps you with your cardiovascular disease. But yeah, Forks Over Knives, I actually enjoyed watching it. It's very compelling. Now, I probably watched it and then made like 2 hamburgers afterwards because I definitely like to eat meat. But if you're thinking about becoming vegetarian or vegan and things like that, or if you just want to improve your diet, it's a very good documentary. But like I said, it really does push the vegan diet all throughout. But with that person, he definitely had measurable improvement in his cardiovascular function and symptoms by going on that plant-based diet for about 9 months. So,
Have you seen Super Size Me? Where that guy was like eating McDonald's 3 times a day.
Yeah, he was eating McDonald's like 3 times a day, and it almost killed him. Yeah, fast food. And when you take nutrition class, I'm sure you'll talk about this stuff, but it's amazing how important.
You were muted that whole time.
What do you mean whole time?
What you were just saying about the supersize me, you were muted.
Oh, well, I was just saying, yeah, my hand was on the thing. No, what I was saying was, you know, Super Size Me is about this guy who ate like McDonald's 3 times a day for a while, and he almost died from it. Like it really screwed him up as far as his health. But
Yeah,
no,
they showed us that in like middle school, and it scarred us for like ever.
Yeah. Well, what I was saying was is that you'll get this in nutrition class, I'm sure. Okay. But it's amazing how much your diet matters. What you put in your body, the whole garbage in, garbage out, or, you know, I mean, what you are, what you eat, all that is extremely true. Even a slight change in your diet can have beneficial effects. I changed my diet about 2.5 years ago. I changed my diet to eat a lot more vegetables. I've lost 25 pounds. I lost it pretty quickly too, and I actually went keto there for a little bit. But yeah, I kind of went keto is like meat, cheeses, and to me it was like the perfect diet in my mind. Like I love meat and cheeses, and I eat vegetables already, so I'm gonna try this keto diet thing. Avoid bread. I never was a big sweets person in general. But I quit drinking alcohol, and I did all, you know, I quit. I haven't drank alcohol in like 1.5 years. But I kind of completely changed my diet, and I dropped weight like that. I mean, I dropped 25 pounds in about 6 months. I actually got all the way down to 200. I'm at 210 right now. But I got all the way down to 200 last summer. And so just that little tweaks in my diet, eating more fiber. But yeah, diet is a huge deal for everybody. You know, even if you didn't exercise, and just sometimes changes in your diet can help improve stuff. So don't underestimate the importance of what you eat. And that's nutrition class. So somebody had a question. Where's the chat at? Is that why we use filters? We're actually going to talk about filters when we get to the blood vessels. Filters are designed to catch blood clots and plaque, and typically blood clots though. And so, yeah, you put a filter, a screen basically, into the blood vessel, so that way if a piece of clot breaks off, the filter will catch it before it makes it to the lungs, before it causes a pulmonary embolism. And so, yes, we are going to talk about that, Sophie, in about a week. So just hang on to that, and when we get to the blood vessels, we'll talk about filters. Yeah, what's unfortunate for us is we could talk about all this for months. You could talk about cardiovascular health and nutrition, and I mean they have a nutrition class, right? But you can have you talk about cardiovascular stuff for months. It's just being a general physiology class. Sometimes we have to kind of cut out some stuff, but I'd love to talk about I could talk about the immune system for semesters. I think the immune system is so cool. All these little side stories that go along with this material. But yeah, the LAD. I was watching a show last night, and they mentioned LAD, and I was like, yeah, I know what that is. It's always good to have that feeling when you're watching these medical shows. You're like, I know what that is. I know what that is. I know what that is. This right here is going to come into play with the chapter 19 lecture stuff, where you have a nerve conducting network in your heart, and its job is to set the rhythm of your heart and control the rhythm of your heart. The heart is really interesting because most muscles have to be stimulated by something to work. Okay, most nerves have to be stimulated. Like when I touch my shoulder, I cause nerves in my shoulder to fire. They fire information. Okay, they call it depolarization. You go back to AMP1. Depolarization is when a cell fires. Okay, whatever cell, it basically is stimulated. And so when a nerve depolarizes, it will fire a message. When a muscle depolarizes, it contracts. Okay, so it basically means stimulation. And then whatever cell you're talking about will have to reset so it can be stimulated again, and that's called repolarization. So depolarization means stimulate, and then repolarization means reset so you can do it again. The heart, what's cool about the heart is those nerves that are inside the heart can spontaneously depolarize, fire a message, spread it through the heart, and then repolarize, reset, and then fire again over and over and over again. I mean, they're doing it every second of your life. Every second of your life, these cells are creating a message, firing it, spreading it through the heart, and then resetting and firing again over and over and over again. I mean, you don't think about just how many times your heart beats, but it's when you add it all up, it's pretty crazy. I mean, the average heart beats over 100,000 times a day. So every day your heart's beating 100,000 times. Plus, that's at rest. It's like 108,640, I think. If you had the regular heart rate of 72 beats per minute, if you add that up over the course of the day, it's like 108,000 beats. Now, when you exercise and do activity and all that, it's even higher than that. Now, if you multiply that by 365, that's how many times it beats in a year. And then you multiply that by 70 years or whatever. I mean, the numbers get staggering. But it's amazing how your heart can do that on its own without you having to worry about it at all. Now, it doesn't mean you can't speed it up or slow it down through the sympathetic and parasympathetic nervous system. But the heart has what we call autorhythmicity. It's capable of initiating its own heart rate or heartbeat without any stimulation from external nerves. You've got there's a cluster of cells, and it's in kind of the back wall of your right atrium, and it's called the sinoatrial node. And every second of every day, these cells are called pacemaker cells. They'll fire a message, and then it will spread down through the heart so that the heart muscles all receive the message and contract. Okay, so here's kind of the special nerve network. There's 4 basic parts to this nerve network. So keep in mind that we're talking about nerves, all right? And these nerves are controlling the beating of the heart. Where did my drawing thing go? So right up here in the right atrium, there's a cluster of cells called the sinoatrial node, all right? Whenever you hear them say sinus rhythm, when they're talking about the heart, sinus rhythm is talking about the pacemaker cells. Like you can have normal sinus rhythm, you know, or you can have sinus bradycardia. That means that these guys are firing slower than they should. You can have sinus tachycardia. That's when they fire faster than they should, okay? So whenever you see sinus, they're talking about the SA node, the pacemaker region. Every second, these cells depolarize and fire a message through the heart. It's going to go from the SA node to this cluster of cells, nerve cells. That's called the AV node. The full name is atrioventricular because it's in between the atria and the ventricles. So the SA node is the pacemaker region. Then you have the AV node here. Now, as it's traveling from the SA node to the AV node, it's going to spread out through the atria, and the atria are going to contract first. And you'll see this later on when we get into chapter 18. I got a little video I can show you. When the message hits the AV node, there's a slight delay. We're talking a split second. There's like a split second delay because we need the atria to contract first, followed by the ventricles. So we don't want them contracting at the same time. We actually need the atria to contract a split second before the ventricles do. So there's a slight delay right there. Then it starts to make its way down the middle of the heart, and it will actually travel through what's called the atrioventricular bundle, or you'll hear it called the bundle of His. Okay, it's spelled H-I-S. It's not his, as in his and her. It's actually named, the doctor's name was His, Wilhelm His, who's a German cardiologist. So that bundle is named after him, but it's called the atrioventricular bundle or the bundle of His. It'll go to the apex of the heart, and then it spreads out through these special nerve fibers called Purkinje fibers. And then once it spreads out through the Purkinje fibers, that's when the ventricles will receive the message and they'll contract. Now, this is all happening in the blink of an eye kind of deal, okay? But we can actually measure the flow of electricity, and that's what an electrocardiogram does. It basically measures this flow of electricity as it moves down through the heart. So if I bring in the slideshow right here, you can see, okay, so it goes from the SA node to the AV node, and if you notice, there's a little slight delay at the AV node. That allows the atria to contract first. Then it goes down the middle, okay, the interventricular bundle right there, and then it hits the apex, and then it spreads out. Now, this picture here shows you a couple structures. So let's bring these guys in. There's a wall right here that divides the two atria. A dividing wall in the body is called a septum. Like, for example, you have a nasal septum, which divides your nasal cavity into two sides, all right? So a dividing wall is a septum, and this one is called the interatrial septum. You see I-N-T-E-R a lot, okay, in anatomy. That means between something. So interatrial septum means between the atria. We all, I don't care who you are, when we're developing in the womb, there's actually a hole in that wall. It's called the foramen ovale, which means oval hole. Okay, foramen means hole. Ovale means oval. We all have a hole there because fetal circulation actually allows blood to move between the two sides of the heart. Okay. But right before you're born or shortly after you're born, that hole is supposed to seal off and separate the two sides of the heart. When that hole does not seal properly, that's when they say that somebody has a hole in their heart. We all have a hole in our heart at some point in development, but for the vast majority of us, it seals up.
I still have that.
Yeah, it seals up before we're born or shortly after we're born. You definitely see with premature babies a lot of times it hasn't sealed yet. It might seal later, but it does happen a lot in premature babies. Sometimes it doesn't seal all the way. Sometimes it seals partially, but leaves a little hole. You know what I mean? But that's why they say when they say it has a hole in the heart, they're talking about that septum right there, the wall between the two atria. And then this wall down here is called the interventricular septum. It's made of muscle. And so he's called the interventricular septum. And that's where the bundle travels. Okay, so you have the bundle coming down, and you have two branches to the bundle. You have what's called the right bundle branch and the left bundle branch. And they take that message down to the tip, and then it spreads out through the Purkinje fibers, and it helps to control the rhythm of the heart. Now, in chapter 19, when we get back from break, we'll talk more about this electrical flow through the heart, and we can talk about EKGs and that sort of thing. How much time do we have? 3 minutes? We got time. I want to, really quick, your heart is controlled by a network of nerves. Anytime you talk about a network of nerves, it's called a plexus. Like we have a network of nerves that goes into our arms. It's called the brachial plexus. There's a network of nerves that innervate structures in your neck area. It's called the cervical plexus. You ever heard of the solar plexus? I don't know if you ever. It's basically a network of nerves that sort of radiates out from a central point, but it radiates out and controls the organs in your abdomen. So the solar plexus is right there, like in the middle of the abdomen. Then you have the network of nerves that supplies your heart, and that's called the coronary plexus. Okay, so this is a bunch of nerves that control your heart. Now, your heart is hooked up to both divisions of the autonomic nervous system. You got the fight or flight. Okay, it's called sympathetic, commonly called fight or flight. And then you have parasympathetic, which is called rest and digest. And then depending on what mode you're in, the heart will either speed up or slow down. For example, when you're in fight or flight mode, your heart's going to speed up. That's the sympathetic nervous system. When you're in rest and digest mode, he's going to slow down. Now, there's a specific nerve that slows down your heart. Okay, so this is part of rest and digest. It's cranial nerve number 10, and it's called the vagus nerve. All right, so that nerve, the vagus nerve, is responsible for slowing down your heart. Now, when your heart rate goes down, that also means your blood pressure is going to go down. Okay, what happens is sometimes the vagus nerve is stimulated to slow down the heart, and it could happen accidentally or it can happen on purpose. The vagus nerve will slow down the heart whenever the pressure in the chest increases. So if you get increased pressure in the thoracic cavity, that will trigger the vagus nerve to slow down the heart. Now, a couple of instances where this happens. One instance is where you strain. When you go, when you strain, that increases pressure in your chest, and that triggers the vagus nerve to slow down your heart. Sometimes that can drop your blood pressure and make you lightheaded, or it could possibly even make you pass out. You see videos of people sometimes where they pick up something heavy, and then as soon as they pick it up, they pass out or they get lightheaded. That's because their vagus nerve was stimulated by them straining, and that triggered their heart to slow down. You also see it a lot when somebody's using the bathroom when they're constipated. If you strain real hard when you're using the bathroom, that could trigger your vagus nerve to slow down your heart, which can drop your blood pressure and possibly make you pass out. If you have a weak heart, that drop in heart rate, okay, it'll make your blood pressure plummet. And then the body's natural response is to increase your heart rate. So sometimes what happens is when you strain, your heart will slow down, your blood pressure will go down, and then all of a sudden your heart will speed up to counteract the drop in blood pressure. And that very rapid change in rate can cause your heart to go out of rhythm and possibly even cause cardiac arrest. And so one of the things that happens sometimes is you see, especially people with weak hearts, like elderly people, is the elderly people have problems with constipation too, but they'll actually die sitting on the toilet. They'll be straining to use the bathroom. It'll trigger the vagus nerve. It'll drop their blood pressure. Then the heart will very rapidly speed up, and it causes their heart to go out of rhythm, and their heart will go into sudden cardiac arrest. So that's an example of, I mean, if you talk to a paramedic, if you talk to people who work in nursing homes, it's a pretty common thing to find people dead in the bathroom from straining. A lot of times they'll fall off the toilet, hit their head, and things like that, but it's something that people with a weak heart experience when they strain too hard, is it could cause them to go into sudden cardiac arrest because it triggers the vagus nerve. Now, you can also purposely trigger the vagus nerve to slow down the heart by acting like you're using the bathroom. And they actually use it for certain conditions like supraventricular tachycardia. So when somebody has a fast heart rate, they'll tell them to bear down like they're using the bathroom, and that will trigger the vagus nerve to slow down the heart. Another place where you might get, when you try to blow something up, if you forcefully exert yourself to try to blow something up, that also is going to increase the pressure in your chest, and that could cause this to happen too. Have you ever gotten lightheaded blowing up like a flotation device for your pool or for whatever? That could be your heart. Yeah, the blood pressure is dropping because your heart's slowing down because you triggered the vagus nerve. It's called the Valsalva maneuver, VALSALVA. But basically, you try to slow down the heart on purpose by increasing the pressure in your chest. One way you can do it is hold your nose, hold your mouth, but breathe out like you're blowing up a balloon, and that will increase the pressure in your chest and trigger your heart to slow down. Some take a coffee straw, like a little tiny coffee straw with that little opening, and they'll blow through it because it's really hard to force air through a coffee straw. But they'll blow on a coffee straw, and that increases the pressure in their chest. So it is used. Okay, now you don't want to do it on your own. Obviously, you would rather wait until a doctor tells you that it's okay to do. But it's called the Valsalva maneuver. And so the Valsalva maneuver, it's a breathing method that may slow your heart when it's beating too fast. To do it, you breathe strongly out through your mouth while holding your nose and your mouth tightly. That creates a forceful strain, which can trigger your heart to react and go back into normal rhythm. That's talking about the vagus nerve. It's increasing the pressure in your chest, and it's triggering the vagus nerve to slow down your heart. And like I said, it could happen when you're straining to lifting up something heavy or straining to use the bathroom. They actually think that's what may have killed Elvis. It actually makes sense about it. Elvis was found dead in the bathroom. Okay, he was severely unhealthy. He was overweight. He had cardiovascular disease. He was addicted to painkillers. His health was really poor towards the end of his life, and they found him in the bathroom dead. And actually, it makes sense to me now that I know more. You ever heard of opioid-induced constipation? Where if you take a lot of opioids, it will actually make you constipated. It's called opioid-induced constipation. I wonder if that's what happened to Elvis. He was addicted to painkillers. He was taking opioids. It made him constipated. He had a weak heart, cardiovascular disease, went to the bathroom, strained to use the bathroom, dropped dead. If you're a paramedic, there probably will be come a point in life where you'll find somebody sitting on the toilet dead. And then you'll have to, they'll be in the seating position. They might be in rigor mortis. And so you got to somehow get them off the toilet and flatten them out to where they can go on the gurney and get taken out. So, but yeah. Little fun fact to think about. Paramedics are a rare breed. Some of the things they see. I don't know if I could do that. All right, let's take our break. 5 minutes over. Go ahead and maintain your 30-minute break and come back in at 1:05. All right. If you have any, we'll just pick up here where we left off and just continue on. Get your lab report out because we're going to fill out your lab report for this lab, the heart lab. We're going to fill it out when we get back from break.